So, let's get started. First thing first, who am I? I'm Malte Pietsch, co-founder of deepset, a young machine learning agency founded basically 1 year ago, pretty much at this space. We also have our office space now in here since then, and we work as an agency, so this means we work on project base for various kinds of clients, all sizes, all industries. Currently working for Airbus, but also for smaller tech startups in various different use cases. The one thing that they all have in common is that they need to extract some information from text data, and that is something you can do with AI, or we call it machine learning. And if you do machine learning on text data, that is called natural language processing, or short NLP. Our founding team, we're actually two techies, me and Timo, both have some background in research, then covered or collected some experience in a couple of startups here in Berlin, and the third guy, Malte Pietsch, covers the business perspective, also with some previous experience in AI and IoT startups. For today, I would like to structure the talk into three main parts. First, a short intro to NLP and why we believe it's a super exciting space right now to be in. Then going a bit into the technology of question answering. And then finally, in the third part, how we can actually apply this in the real world use cases. And the one that we are currently focusing on is M&A, due diligence in M&A. Why is NLP important? What we believe is that language is just the most natural way of humans to exchange information. And if you think about it, just look at this number here. Every day there are 270 billion emails being sent. And that is with all tools, all dedicated software solutions that we have there, like SAP, Salesforce, you name it. In the end, people still prefer in many cases to write a short, simple email because it's the simplest way, and people are lazy. But this means also for companies that a lot of information is actually stored in an unstructured way. As we also heard in the previous talk by Andreas, many information in companies usually is not stored in a nice SQL table and nice Excel sheets. It's usually in some emails, some PDFs, some reports, and some other types of unstructured data like images or videos. And this, on a global scale, makes up around 90% of data that we're actually talking about. So if we really want to exploit the information that is stored in the company somewhere, we need to find some methods to get this buried data out of the unstructured documents. And the nice thing is that there's actually some techniques to do that. And they are called natural language processing. It's nothing new, it has been around for decades, but until a few years ago, it was mainly a topic for research because performance was just not good enough. I would say this changed probably 2 or 3 years ago, and with some breakthroughs in the technology, but also computation and data, we're now there that there are actually a lot of use cases where performance is just good enough to actually apply it in production in real world scenarios. One use case that you actually see here, it's probably one of the most prominent ones, speech recognition. You probably discovered 2 or 3 years ago, everything started with consumer-facing devices like Alexa and so on. And all of a sudden they were there. And this is only because there was this gap being closed that performance of speech recognition became good enough for real world and for businesses. But the same is true for other use cases, as entity recognition, extracting concepts from data, or also question answering that we will see a bit more in a few minutes. The main idea is always the same. You have some unstructured text that you feed into some kind of model, which can be a neural network or anything else, and then you generate some output that you're interested in. It can be translation, it can be sentiments, so for example some emotions, or certain topics that are detected in the text. In our case, what we want to do today is feed in some text, feed in a question that we're interested in, also in freestyle text, and then get an answer that actually asked this question. But now, when we talk about question answering in general, I would say any technology in machine learning or AI, for us it's really important to differentiate between all this AI hype and buzz that is out there and the real use cases that are actually feasible today, that you already produce value, because we believe that it's really important to separate between those two, and they often get mixed up nowadays in the media, but also in discussions with businesses. So let's briefly highlight what I'm talking about when I'm saying question answering, and what are the maturity stages that we see these technologies end up right now. One kind of question answering that works pretty well is the one that is highlighted by the Stanford question answering dataset, very popular research dataset where researchers benchmark their models against. And what you have there is a short abstract of text that you feed into a model. And then you have some kind of questions, and then a very short fact-based answer. So two important things: texts are usually quite short. Second, the answer is really a fact-based answer, so something that needs to be in the text. You can not really ask philosophical questions to these kind of models. It's all about facts. But for these kinds of models, the current technology works pretty amazingly. Last year in summer, we actually first time tracked the human benchmark, so the models are actually better than the average human. What is more challenging though is if you do not feed in only a short text, but a whole book or a couple of books. Then it gets more complicated, and it's harder for the model, of course, and the gap between the model performance and human benchmark is quite big. But even for those cases, there's a lot of rapid movement out there, and basically the performance of models increases on a weekly basis. So super exciting field. I'm pretty sure that there will be human benchmark within maybe the next year, but not quite there yet. If we look back at last year though, and this is for a similar problem type like this first Stanford question answering data set, what you see here is we have down there the timeline, and then on the Y scale, model performance. And what we see within last year, there was a lot of improvement regarding model performance, and we're getting closer actually to human benchmark here during the end of the year. And then there we have this huge spike happening somewhere around October, November. And this spike caused a lot of excitement in the NFT community, I would say. Everybody was going crazy. And this was not only true for question answering, but also for a lot of other problem types in NLP. And I will briefly highlight why this is and what's behind that. And the guy involved there is Bert, and the concept behind it is called transfer learning. To understand what transfer learning is, we need to understand what the classical machine learning approach is. In the classical approach, you take some problem type that you want to focus on, for example, question answering or sentiment analysis, and then you collect some data, some training examples, and after a while you get annoyed, so you have quite a small data set usually, you train your model on, and then you have some predictions. But it's always on this isolated tasks. So one data set for one task. The problem with these kind of approach is that modern architectures from deep learning, they usually perform best if they really have large data sets. So one idea is now to use transfer learning. And transfer learning is the idea or the approach that you take a huge data set. So we were talking about full Wikipedia, thousands of books, and you train some kind of model, some language model on top of this data. And this model learns some basic concepts, some basic general understanding of language. And this knowledge is then actually transferred to your target domain, to your target problem. And then you learn a smaller data than what you're actually interested in, but not starting from scratch, but with some initial knowledge about language and what you actually do. And this is not a very new idea. It was also applied in images a few years ago. But for NLP, for text data, that was super hard to do. And now I would say last year there were a couple of models, but the really interesting one was the one from BERT. It's called BERT and it's from Google. And they released it in October. And that was the model causing the spike that we saw. And the idea is, as I said, training on a very huge corpus and then applying it on some smaller tasks. I won't go into the details of the architecture right now, also because I think it's not the most techy audience probably here, but I'm super happy to answer questions afterwards, either in person or from scratch. So let's now dive a bit into the application. What can we actually do with that? What can we do with BERT? What can we do with question answering? One problem that we came across is in the M&A space. So if one company wants to buy another company, they don't want to buy it without knowing what they buy, of course. It's like when you buy a car, you also just not hand over the money. You want to inspect it first, check the tires, check the brakes and so on. And the same is true for a company. So what happens is usually that the sell side uploads a bunch of data, financial reports, legal documents, HR contracts and so on, to some kind of Dropbox or virtual data room. And then a huge bunch of investment bankers, consultants, lawyers go into this data room and analyze the data, answer the questions they have, and come up with some conclusion, and use that conclusion to actually bid, to make an offer, a price tag on this company. The problem with that is it's super slow, it's very expensive because investment bankers, lawyers are not the cheapest law force you can imagine, and it's a lot of repetitive questions, repetitive tasks. As Andreas mentioned, I would also say like 30% is just really stupid work, and they are highly skilled workers. They should rather focus on the difficult question, difficult tasks. So one idea is now to apply this kind of question answering model to this domain. So you feed in some questions regarding the M&A process, regarding company data, what was the revenue for a certain product line, what are the most relevant partners for R&D, and the model automatically crunches the documents, comes up with an answer, and also the relevant documents to answer that. And at this time, I would like to do a short demo. So some cool demo that is out there, public domain, so you can also try it at home from NLP. They have called here model machine comprehension. And the model you see here is actually from early 2017. So if you remember this graph in the beginning, it's really worth performance, not cutting edge at all. But nevertheless, it's a pretty cool tool to explore the capabilities of these kind of models. So now let's check. It's some section with some facts here from the Amazon annual report. And let's pose some questions to that text. So I think, for example, somewhere there is mentioned the revenue of AWS. And hopefully, yep, so now we get answer 20 billion, and also the passage highlighted in the text where it got the information from. So here, excited to see Amazon Web Services, 20 billion revenue, and so on. There are actually a lot of questions that now we can ask. I think we are a bit running out of time, so I won't test more of these. But I really encourage you to play around with that tool. The cool thing is that it's not only possible to answer questions that are very similarly mentioned in the text, so if it's really the same keywords, but it also works if you use synonyms or just contextual meaning. And that's actually the exciting part right now. we're doing right now is building a question answering model, particularly for this domain of M&A, because what you've seen earlier in this demo, it's really a generic model working for any kind of language, any kind of documents. If you really want to bring this into business, you need some tailored version, particular for a particular domain, particular keywords that are important, type of questions that are more important. And that's why we're currently exploring this direction together with two lead customers where we have a co-innovation setting. They bring the data and the expertise from the domain. We bring the technology and machine learning expertise. And together we build some kind of smart data room where this question answering capability. Of course, I believe that's not only interesting for these two clients. It's a big market. If you actually look in Germany to the M&A market, we have a deal volume of 96 billion euros every year. And this is split across around 800 deals. And if we assume that we can speed up some of these deals or some of these due diligence processes actually lead to deals, then it's actually a pretty interesting market, and that's why we want to explore it further. If you're also active in this market, super happy to talk, share experiences, share opinions. This is then from my side. I also put some helpful resources maybe for the more tech-related, tech-interested persons of you regarding BERT, the architecture, the taper, to GitHub repositories. The one here is the official one from Google, implementing TensorFlow. And then there's also a very popular one from Python. That's the one where we also contribute. I would say we released one of the key features a few months ago and are now actively developing this model further and apply to use cases. That's it from my side. Happy to answer questions.